Think about this. You sip a glass of lemonade, pop open a fizzy soda, or simply take a breath. Seems ordinary, right? But there's something fascinating happening in each of those moments. What do they all have in common? Their solutions, uniform mixtures where one substance dissolves seamlessly into another. In this video, we'll dive into what makes a solution, explore how concentrated it can be, and uncover how it compares to suspensions and colloids, three hidden forms of matter that shape our everyday world. Let's start with the basics. What exactly is a solution? According to your NCERT textbook, a solution is a homogeneous mixture of two or more substances. That means it looks completely uniform from the first drop to the last. Even if you zoom in under a microscope, you won't see any separation between the components. Now, every solution has two parts: the solvent, the substance in larger amount that does the dissolving; the solute, the substance in smaller amount that gets dissolved. Take sugar water for example. Water is the solvent and sugar is the solute. Mix them well and you have a sweet, clear, uniform solution. Did you know that solutions aren't just liquids? They come in many forms and you encounter them all the time. Solid in liquid like salt completely dissolving in water; gas in liquid, the fizz in your soda. That's carbon dioxide dissolved in water; gas in gas, the air you breathe is a mixture of gases like nitrogen and oxygen. Solid in solid. Ever seen brass? It's an alloy, a solid solution of copper and zinc. Now, what makes all these solutions special? Their particles are extremely tiny, smaller than 1 nanometer. They form no residue, which means they're stable. They don't scatter light, so no Tyndall effect, and you can't filter out the solute using ordinary methods. That's why your lemonade looks so clear, even when it's packed with flavor. Let's now explore a key idea: the concentration of a solution. It tells us how much solute is dissolved in a specific amount of solvent. In simple terms, how strong or weak the solution is. According to NCERT, a solution can be dilute, has less solute; concentrated, has more solute; saturated, can't dissolve any more solute at a given temperature; unsaturated, can still dissolve more solute. Let's look at a useful formula to calculate this. Mass percentage is equal to mass of solute divided by mass of solution times 100. Here's an example. Times mass of solute is equal to 40 grams times mass of solvent is equal to 320 grams times, so total mass of solution is equal to 360 grams. Now, applying the formula, mass percentage is equal to 40 divided by 360 times 100 is equal to 11.1% times spelled mass percentage equals open bracket 40 divided by 360 close bracket multiplied by 100, which equals 11.1%. This means 11.1% of the entire solution's mass comes from the solute like salt or sugar. The rest is solvent, usually water in everyday cases. Let's now explore a different kind of mixture, the suspension. A suspension is a heterogeneous mixture, meaning it's not uniform. Here, the solute particles don't dissolve, but instead remain floating or suspended in the liquid. A classic example: muddy water. Let's look at its properties. The particles are large enough to be seen with the naked eye. They scatter light, so the Tyndall effect is visible. Given time, the particles settle down, making a mixture unstable, and yes, you can separate them easily using filtration. That's why, if muddy water sits still, the mud settles at the bottom and the water clears on top. Somewhere between a true solution and a suspension lies a special type of mixture, the colloid. A colloidal solution may look uniform, but under the surface, it's actually a heterogeneous mixture at the particle level. You've seen colloids all around you. For example, milk, fog, shaving cream, even jelly. So what makes colloids unique? The particles are small, but still large enough to scatter light, This scattering is known as the Tyndall effect. They're stable. The particles don't settle down over time. You can't filter them out like suspensions, but you can separate them using a process called centrifugation. In every colloid, the dispersed phase is the particle-like substance, and the dispersion medium is what it's floating in. Alright, time for a quick quiz. Let's put your knowledge to the test. Can you classify these mixtures? Let's go one by one. Soda water, a clear example of a solution. It's homogeneous with carbon dioxide gas dissolved in water. Milk looks uniform, right? But it's actually a colloid, a heterogeneous mixture with tiny particles that scatter light. Soil, definitely a suspension. It's non-uniform and its particles settle when left undisturbed. Air, yes, even air is a solution. A uniform gas mixture of nitrogen, oxygen, and more. Blood, a fascinating colloid with plasma as the dispersion medium and suspended cells as the dispersed phase. Just remember, mixtures don't always look different. Some, like milk or air, might appear uniform but behave very differently under the microscope. Let's quickly rewind and lock it in. Solutions completely homogeneous, stable, and do not scatter light. Suspensions clearly heterogeneous with visible particles that settle over time. Colloids, they in-betweeners. They're stable, appear uniform, and show the Tyndall effect. So whether it's the air you breathe, the milk in your glass, or the muddy puddle after rain, you now understand the science hiding in plain sight. Stick around because there's much more to explore in the magical world of matter.